I'm going to do a demonstration about buffers.
Here are two solutions, A and B, to which I've added universal indicator. Here's the color key. As you can see, both of these solutions are around pH 6, or very slightly acidic. Now, I'm going to add concentrated sodium hydroxide, which is a strong base, to each solution. It only took one drop of strong base to dramatically raise the pH of solution A. After one drop, the pH of solution B hasn't changed. Let's reset. Here are the same two starting solutions, A and B, with the same indicator. But this time I'm going to add concentrated hydrochloric acid, a strong acid, to each solution. It only took one drop of strong acid to dramatically lower the pH of solution A, but the pH of the other solution hasn't changed. Let's look at our pairs of solutions. When we added a strong acid or base to solution A, its pH changed dramatically after just one drop. When we added one drop of acid or base to solution B, its pH stayed the same. Let's add more acid and more base to solution B and see what happens. It takes much more acid or base to change the pH of this solution by the same amount. Now, how is solution B able to resist changes to its pH when strong acids or bases are added? How could we make and use such a solution? In this video, you'll find out.
A buffer is an aqueous solution containing both a weak acid and a weak base that are a conjugate acid-base pair. The buffer shown contains the weak acid acetic acid and its conjugate base acetate. These species are dissolved in water. Water molecules are not shown in this animation to draw focus to the buffer components. A buffer solution has the ability to resist changes in pH upon the addition of small amounts of either acid or base. Choose to add a strong acid or a strong base to the buffer by clicking one of the buttons. Only hydrogen ions, H+, from the hydrochloric acid are shown entering the solution. Chloride is not shown because it is a spectator ion. It does not participate in the reaction. The strong acid H+ reacts with the base component of the buffer acetate, CH3COO-, producing the acid component of the buffer acetic acid, CH3COOH. The buffer has resisted a change in pH by removing strong acid, H+, from the solution. Only hydroxide ions, OH-, from the strong base sodium hydroxide are shown entering the solution. Sodium ions are not shown because they are spectator ions. They do not participate in the reaction. The strong base hydroxide, OH-, reacts with the acid component of the buffer acetic acid, CH3COOH, producing the base component of the buffer acetate, CH3COO-, and water. This buffer has resisted a change in pH by removing the strong base hydroxide from the solution.